So in the previous video, we discussed how we can get the area of that blue portion of this graph, and we said that we can simply get the area of the green portion, or sorry, of the green portion and the yellow portion, and subtract the green from the yellow, and that green subtraction from the yellow gives us the blue portion. And you could think of it like, if we have some sort of circle, for example, and we want to take the area of this little segment of the circle. Well, what we can do is take the area of the whole thing of the circle and then subtract out this portion, and that gives us the area of this portion right here. So that's a similar thing we're doing. Now I want to think about an actual example, and we want to use functions which we have equations for to make this more concrete. So let's say the two functions we want to work with today in this video is, first of all, f of x is equal to x squared. So f of x is equal to x squared, and g of x is equal to the square root of x. Actually, let's do a different color for g of x so we can show it nicely on a graph. G of x is equal to the square root of x. All right, let's do some graphing here. So first, let's draw our y-axis and our x-axis. And again, once you do a few of these, you will get much better, and you actually might not have to draw them, but it does help drawing these, and I'll show you why in a second. All right, let's graph f of x first. So we know how an x squared function looks like. It's just a parabola, and in this case, let's just say, I forgot to say what the question was actually. Here, let's say the question says, find the area in between these two curves from x is between 0 and 2. So area in between from x is 0 to 2. So we only care about the positives in this case up until 2. So I'm going to graph the parabola. I'm going to graph the parabola from 0 to 2, which will look something like that. And we'll say this right here is x equals 2. And then also I'm going to graph the square root function from 0 to 2. And before I do that, I want to figure out where these two intersect. And so that'll help me actually graph the square root function relative to the x squared function. So how do we figure out where these two intersect? Well, we can just set them equal to each other, right? X squared is equal to the square root of x. And we know that they intersect at 0. When x is 0, this is the solution. And also, when x is 1, this is a solution, right? And those are the only two solutions. So let's actually make this here. Let's change this from 0 to 1. So we want to find the area from 0 to 1. Okay, let's go ahead and graph this. Well, the graph of the square root function relative to the x squared function will look something like this. It will start off being greater than x squared, right? Because if you plug in 0.5, for example, 0.5, this will give you a number that is less than 0.5, but this will give you a number that is greater than 0.5. So the graph of the g of x will be above the x squared graph for the domain 0 to 1, and then it will be below it afterwards. And if that didn't really make sense, I encourage you to graph these two on Desmos so you can clearly see what's going on. Let me do the same color. So we're doing our g of x function. It should look something like that. And again, this right here is 1. This is x equals 1. Okay, so our goal is to find the area in between these curves. So this shaded area right here. So let's use our general formula that we derived in the last video and find this area. Well, we can find the area of under the curve g of x, right? Which I'll do it with turquoise, which will be this. Let me do a little marker here. So this is x equals 1. That's where we stop. So this will be the area that we're finding when we take the integral of g of x, right? And then if we take the integral of f of x, I'll do a different color. This is the area that we are finding. So if we get the turquoise area and we subtract out the blue area from it, we get the orange area. So essentially in this case, what we want to do is take the integral from 0 to 1 of g of x, which is the square root of x dx, and then subtract the integral from 0 to 1 of x squared dx. So I would encourage you to pause the video here to think about exactly what I mean by this right here. Alright, so let's keep going. So now all we have left is to just take the integral of these two and just evaluate it at 0 and 1, and we find the area. So we can actually rewrite this by the properties of integrals as the integral from 0 to 1 of the square root of x minus x squared dx. And this is something we can do. This is equivalent. And you can, and I encourage you to actually just try this on your own. Take the integral of this from 0 to 1, take the integral of this from 0 to 1, subtract them, and notice that it will be the same thing as this. Alright, so now we're going to use the anti-power rule to integrate, and then we're going to evaluate the definite integral, and we'll be done. So x, the square root of x, we can rewrite as x to the 1/2, and then x squared, we can just leave it as x squared, and this is just equal to the definite integral from 0 to 1. Or actually, let's do the anti-power rule now. So x to the 1/2, we add 1 to the power, we divide by that power. 1/2 plus 1, that's 3/2. And if we divide by 3/2, we can essentially multiply by 2/3. So it's going to be 2/3 x to the 3/2 minus x to the, well, 2 plus 1 is 3, and then we divide by 3. And if you don't know the anti-power rule, I encourage you to watch that video before watching this. And then we take the definite integral from 0 to 1. Here, I'm going to go right here. So now we plug in 1 for each of those values. So we get 2/3 times 1 to the 3/2 minus 1 to the 3rd over 3. That's just 1. And then minus 0. So this just gives us nothing. And then this is equal to 2/3 minus 1/3, and then that can simplify to just 1/3. So the area in between these two curves from 0 to 1 is just 1/3.